we established that climate change is occurring through evidence and whatnot. And then we also talked about how we know that current climate change is due to greenhouse gases rather than more natural cycles like the Milankovitch. Now let's talk about what's actually changing. So this will be the first time you notice where I talk about the words global warming. Global warming is an effect of the current climate change. They are not identical terms and they shouldn't be used interchangeably. But the effects I'm going to talk about for the next 3 slides are going to be ones that are directly from global warming, so I'm going to use that term here. Okay, so what do we know? Changes from global warming that are going on right now. These aren't predicted ones. I will do predicted ones in the next video, so make sure you clearly delineate what's happening now versus what's predicted to happen. So they throw a lot of the warmest years around, and your book talks about 8 out of the last 10. I don't even want to go there. I went directly to NOAA. There's the link if you want to ever go look it up. 15 of the last 16 hottest years have been in the 2000. So from 2000 to 2015, which is officially the warmest year on record, have all been in the last 16 years. Interestingly, the one that is outside of that, number 4, I believe, is 1998. Which, as you should know from last chapter, was the really large El Nino year, the biggest one besides 2015. So what is the effect of the climate change? It's getting warmer, and it's getting warmer on a global scale, not in one neighborhood or in one country. This image below is off of the NASA website, the same one I gave the link to, where can you see the scale? I hope you can. It goes all the way up to 3 degrees. There are pockets of cooler, if you know, especially around southern Greenland, and right around the North Atlantic where that deep water forms, which is good, I guess. But in general, most of the planet is warmer. And one of the things we should probably mention is that it's not getting warmer evenly. If you notice, what we would consider like upper temperate, tundra, even polar regions are showing greater changes, while in the southern hemisphere, it's much more reduced. And even in the Antarctic, it's actually cooler than normal. These are some numbers you should know. Overall, our rate of change of warmth since 1880 has been about 0.07 degrees Celsius per decade, and that was only up to 1970. 1970, it jumped to 0.17 degrees Celsius, and it's going to be even warmer for the last 10 years. They haven't calculated it yet, but remember that 2015 was almost a full degree Celsius warmer than any other year on record. So that's fun. Change the slide. So here are the changes that we're already seeing from our warmer globe. Increased storm activity. You know that warmer surface waters are a result, especially for El Niños. When we have warmer surface water, we can have stronger storm events because typhoons, like the ones they've had in the Pacific this past year, and hurricanes get their energy from surface water. So the warmer those surface waters, the stronger the storm. And because of this warmth, we have longer storm seasons. I believe hurricane season is June 1st to November 1st. There was the first hurricane outside of that, I believe, in 2008. In addition, you were also seeing weather extremes. I probably should have said droughts/floods. You know in California that there's a very large drought going on that's related to El Nino. But we're having droughts throughout the world. There are places where it hasn't rained in years, which is kind of horrifying if you think about it. Changes in precipitation are also a consequence of global warming. And one of the concerns is even if your overall net amount of precipitation is the same or even slightly increased, as it is in the United States, we're getting more water than we used to. One of the problems is it tends to be associated with those storm events. So when it rains, we don't get the gentle soaking rain, we get a big storm. And one of the problems is when you have large storms, the water, the groundwater only takes up some percentage of it and the rest runs off. So even though in the US we are having, as a country, an increase in precipitation, there are more areas that are having water restrictions and water problems than ever before because so much of that water now comes in storm events where it can't be taken up. They're also having extreme heat waves and cold spells. We tend to get a little center focused and we're like, oh yeah, it was so warm in December. And then right now it's been fairly chilly. I'm talking about the kind of heat waves they've had in Europe over the 3 or 4 summers over the past 10 years where like people die. These are heat waves where it's not, like 90 degrees for 5 days. We're talking it's like 10 to 15 degrees longer than warmer than normal. And people die. People who have health issues, it's leading to air pollution. Additionally, there are areas that are having cold spells, sort of the range of temperatures is increasing. I can't remember where it was. I think it was Mexico. They had a snow that they'd never had before. So changes in weather. The biological shifts, we could do an entire chapter just on that, and obviously something I'm very interested in, as invasive species was my graduate work. But we are seeing right now in your life changes in species distribution. I think the most obvious one that I can think of that you will notice is the stink bug, that marmoladed brown stink bug. That's its full name, marmoladed. Not like marmalade, just because it's speckled. The brown stink bug didn't used to be here, and it's a more southern species. And because we've had warmer winters with less frost, it's been able to push upward. So we're seeing changes in species distribution. For those of you in research like Alex Sipis, you can actually, his entire research project was showing how these species are changing their distribution. Most species are trying to shift poleward to stay in the same temperature range. We're seeing a lot of problems in the tropics, though, because in your lifetime, it's entirely possible that frogs will be, as an entire phylum on the, not phylum, class, will be on the endangered species list. And the concern with them is a lot of them live in rainforest and mountainous areas, and they don't try to shift northward. They end up moving farther and farther up mountains. They're already in habitat restricted areas, and as they have to move farther uphill to stay in an area where they can reproduce and survive and whatnot, they're getting less and less habitat. So there's concern that these animals will just go. Amphibians in particular are very susceptible to changes in temperature. There's a concern, everybody's talking about Zika virus right now. You will see an increase in disease vectors. So the Zika virus is not new. It's mosquito, unfortunately, is beginning to move northward. I believe it's been found in several of the southern states, Florida, Texas. It will likely move northward in the summer, and if we have another super mild winter like we had, it could move even farther north after that. So, and it's by no means limited to just this particular disease and this particular mosquito. It's hard to assign an amount because as a species we're becoming more global, but the disease vectors that have typically been limited to areas that are warm year round in order to maintain the disease in the population, those are beginning to spread outside areas they used to be trapped in. So these changes are all have to do with the cryosphere or ice and tundra and whatnot. And so some of this is really, really new. But generally speaking, Arctic sea ice has decreased 13.4% each decade since 1980. It's just going away. And there are periods of time when the Arctic Sea is completely ice-free, which is, especially in the 90s, was like shocking to people. It's entirely possible within the next 10 to 20 years that the Northwest, that we will be able to take ships from Europe and the Northeast Atlantic coast of the United States through the Arctic Circle and into the Pacific, which ironically will have a nice effect. One of the largest sources of CO2 to the atmosphere is transportation of goods, and that's a lot shorter. They don't have to go through the Panama Canal. So, yay, a positive maybe? So sea ice decreasing quite a bit. That's a good number. If I'm going to ask you some random numbers, I like the 13.4. This third bullet rather, was all over the news this past week, though the report was from last year. The Antarctic is seeing a loss of glaciers, mostly in the western part of the continent, and mostly, as you can see, maybe from this slightly confusing graph, along the peninsula. That peninsula is the one that's of great concern of losing most of its sea ice. And if you think about it, we know that the water's warming pretty fast, and that's surrounded by water with less center. But one of the interesting things, let's go back one, is that this area, which in here and a little bit in here, let me go back. This area that is like purpley and we have some gray, is actually seeing less issues. And there are areas of Antarctica that are having huge gains. I keep doing that. Huge gains in the amount of glaciers. This is a good thing. Right now, Antarctica is gaining slightly more sea ice than it's losing every year. excuse me, not sea ice, glaciers. And this is really good news because when that sea ice does begin to melt, and there's concerns that eventually the western half will outpace the western's decrease in glacial ice will outpace the east gain. When that happens, it'll begin to affect sea level. So that's a concern, and that'll probably happen in the next 10 to 15 years, though it's being very closely monitored by NASA. But it's good news. It's very good news that Antarctic ice is gaining. That's good. One of the things we've also seen around Antarctica, and a lot of climate skeptics were like freaking out about this one, was that their last winter or summer had some of the largest amounts of sea ice around Antarctica ever seen. But that's not good news necessarily. Think about it. If we do have melting, especially along that western edge of the continent, there's flooding the surrounding waters with quite a bit of fresh water. As you know from that very first chapter, and maybe even the last one, the fresh water is not going to mix in very well. It'll mostly sit on the top. And as you get winter there and a cold snap, that fresher water will begin to freeze. And you would expect when you have melting glaciers to at least initially have an increase in corresponding sea ice. So we've been seeing that. There has been absolutely an increase in Antarctic sea ice. And again, that's seasonal, so it kind of goes away in the summer. So it's not like we're locking it out of the ocean system long time. Finally, sea level rise. Sea level rise is very hard to measure on a global scale, but this number is global. Since 1870, we believe that sea level has risen about 50 centimeters, or about a half a meter. That number's contested, I'll be honest. Some people put it as low as 10 centimeters. It doesn't really matter. There are places on the planet where sea level rise is visibly occurring. There are countries where they're disappearing. We'll talk a little bit more about why it's mitigated in areas like this with regards to actually as glaciers change and shift. There's this process of the land called isostasy, where the land actually shifts as weight's lifted off it. Believe it or not, the plates just bounce back. So that's something that's actually occurring, and it's kind of offsetting sea level rise, which is nice. I don't know how long it'll occur for, but it's useful. Finally, this last little bit is a blue box in your book. It's about the SOFAR channel. The SOFAR channel, I don't think I talked about, even though it was briefly mentioned in the chapter on seawater. SOFAR stands for sound, fixing, and ranging. If it sounds like sonar to you, it should. It's an area of at about 1,000 meters down, where the salinity and the temperature give it a unique density. So you may remember from physics that when you have liquids that have different densities, light and sound don't travel as they treat that boundary, that picnic line, as a physical barrier. So the sound actually bounces off the picnic line at the top of the SOFAR channel and below it, and causes most electromagnetic waves, including light and sound, to be trapped there. So the SOFAR channel, a scientist by the name of, I think his name's Walter Munk, decided in the 90s to try to measure the changes in the entire ocean's temperature, because so far we've been limited to surface waters, on a global scale using the SOFAR channel. Now, the SOFAR channel is found in all the major oceans: North Atlantic, South Atlantic, Pacific, Indian, all that. And what he did was he would bounce long sound waves from this place called the Hurt Islands in the Indian Ocean, and bounce them along this, using hydrophones, out along the SOFAR channel, and measure how long it took for them to be hurt. So we're talking about long distances, thousands of miles. And the idea is that as you warm up a fluid and put sound through it, the sound will actually travel faster. So the idea was they would measure these speeds, and if they come back in 5 years and do it again, and the sound is traveling faster, then we know that the world's oceans are getting warmer. And that is in fact what they found. They found that in not just surface waters, but also the entire deep water is already beginning to show changes in global temperature. There is some concern about this over the effects of marine life on the second time they went and used the SOFAR channel. Oh, the experiment. The experiment is called ATOC, or Acoustic Thermometry of Ocean Climate. I suppose that's an acronym you should know. There was concerns because within a few days of them doing the second major test of the SOFAR channel in the ATOC experiment, there were a large number, I want to say more than 4, dead large whales. Indian Ocean is one of the areas where we don't really study whales very much, but they do live there. They do utilize that area. And there are concerns that pushing out these loud noises into this channel that we know they use to communicate could be causing problems. So NOAA's very quick to tell us, hey, that's fine, don't sweat it. But there are actually studies ongoing to check on that. So this is where we're going to stop for this video.